Page 347, number 41, asks us to find the value of sine theta, cosine theta, and tangent theta for the given quadrantal angle. Now, quadrantal angles are angles whose point on the terminal side lies along one of the coordinate axes. So we have to figure out which axes we're on based on negative 7 pi over 2. So the negative sign tells us that we're going to be traveling in a clockwise direction. So 7 pi over 2, we have to figure out how far around we're going in a circle. So it goes back again like we did in number 29. We have to figure out how many trips around the circle 7 pi over 2 is and where we'd end up. So as we had stated before, 360 degrees is one trip around, which is 2 pi radians. So if we change that to halves, we get 4 pi over 2. So what we can see is that one trip around is going to be 4 pi, and we're going to 7 pi. So it's not quite 2 trips around. That would be 8 pi. So what I can do is, if I take 7 pi over 2 and subtract off the one trip around, what I get is 3 pi over 2, which is 3 halves around. So it's going to look like this. I start here at the x-axis. I'm going to go the whole way around, and I'm going to go around 3 halves again, which would put me right there on the positive y-axis. Also, we mentioned in the last video with number 25 where exactly P is from the axes, or the length of P in either the x or the y direction, is really arbitrary, since any triangle we would draw would be similar depending on the length of P, so the trig functions would be the same. So we're just going to make this length, this point where P ends up right here, as 0, 1, the distance of 1. So all our trig functions will be in simplest form. So sine of theta is going to be the y value at that point. So that's going to be 1. Cosine of theta is going to be the x value at that point, which is 0. And tangent of theta is going to be y over x, which is going to be 1 over 0. And that, of course, is undefined. So there is no tangent value at that point.